Node.js. So by a show of hands, who's heard of Node.js before? Almost everyone. OK. So how many people think they know enough about Node.js that they understand the core of how it works and why it's a little bit different than what you might be used to? OK, quite a few people. For the rest of you, that's kind of what I'm aiming to do here today. So for some of you, then this will be a rehash. So I want to cover 4 things. So what is the main theory behind Node.js? Why did its creator create it? And what problem was it trying to solve? What are the challenges that you get out of that programming model? And then also what the benefits are, and a few things to get you smarter on Node. So the first one, the theory, kind of the most important part. So if I had to distill the whole theory behind Node.js onto one slide, it would be this slide, which is actually the same slide that its creator, Ryan Dahl, presented in 2008 at, I believe it was JSConf, when he sort of was launching Node into the world. And so what we're showing here is for a certain number of operations down the left, how many CPU cycles do they take generally? Now these aren't hard and fast statistics across every computer, but the magnitudes are what we're paying attention to here. So if we're talking about L1 or L2 caches, we're talking 3 and 14 CPU cycles respectively. RAM, 250 CPU cycles. But then when you get down to disk and network, it's 41 million and 240 million cycles. Questions at the end, thank you. So what's your question, Aaron?
I was going to ask, what was on the other end of the network?
I don't know. This was taken from his slide. Like I said, this is the actual number of cycles are not important. It's the relative magnitude changes. Okay.
Don't take any more questions from him.
You're banned from future questions.
Yes. So generally what I would say is you never actually create a table when you can create a chart. So here's the chart version of that. Although I don't think it's quite as useful because you can't even see the L1, L2, or RAM because the magnitude of the disk and network are so large. So when you look at it a different way, if you look along the left-hand side, those operations compared to the top ones, how much faster are the ones on the left than across the top? So for instance, the first number 5 there, L1, accessing L1 cache, is about 5 times faster than L2. So as you go across, you can see that accessing cache, is maybe 80 million times faster than accessing something over the network. And this is times, right? So orders of magnitude. So this is really what Node.js's core theory is in life, is that I/O compared to other operations that you do on the processor takes much, 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 much longer. So we'll talk about why that's important. And that's important because Node assumes that if you're an I/O-bound application, like many are, that you spend a lot of time waiting. So we take this theoretical request that we're going to take from, let's say, a web server. The little green slices, if you can see them, are the actual time your application is spending doing something. And the gray parts are when you're waiting for I/O. So for in this example, you have, right in the beginning, you're going to route the request. So maybe your application gets the request, parses the URL, decides which controller to invoke, passes it off to the controller, and the controller then maybe queries a web service or accesses the database, and then waits, right? Then it waits, and waits, and waits, and waits, and waits, and waits, and waits. And then eventually it gets to do something a little bit more. And then in this example, we're going to write to a log file, and then we're going to wait again for a while. And finally, we're going to format a response and send that back. So the theory here is that any request is spent, a lot of the time is spent waiting on the I/O to return. So waiting on the database results to come back, or waiting for a web service request to actually send you something back, versus how long it takes you to actually process it on the CPU. So if we want to scale that with a threading model, in this example here, we have 4 threads, so we can handle up to 4 concurrent connections, right? And what are each of those doing at most of the time? Nothing, right? They're waiting. They're waiting on I/O. So if we want to be able to handle a lot of connections at once, we need a lot of threads. And so then we start getting into having a lot of context switching overhead. We're eating up memory with our execution stacks. And also, if we have any kind of shared state, concurrency gets a lot more difficult. So what some platforms have done to deal with at least the concurrency piece is that they'll use processes instead of threads. So in this example, we have 4 processes. for up to 4 concurrent requests, and most of them are doing what?
Nothing?
They're waiting, right? They're not doing much of anything. So in this example, it's very much like the thread one, only we're actually using a lot more memory than we were with threads. So what Node's whole goal in life is to do is to take those little gray bars and pull them out and delegate that all to a sort of internal thread pool, and also to, where possible, a native asynchronous I/O APIs that can use interrupts to call back into the system. And so while it's delegating the I/O parts and the waiting, it can handle other requests. So its whole goal in life is to get all that I/O out of the way and start working on the next CPU bound thing. Does that make sense? Aaron?
When you mean waiting, you actually mean blocking or waiting?
I mean blocking. So if we're talking about Node.js, here's sort of the conceptual model. You have an event queue, which you can think of as code that needs to be executed, and a loop. In this event loop, we'll say when you start your program, you're going to have code that's going to be sitting on the top of your event queue. The event loop's going to come around, grab something off the top of that queue, and execute it. If it needs to do I/O, it will get delegated off to this thread pool or async APIs in the operating system, and then it will continue the loop back around and grab the next thing off the event and execute that, possibly putting something more over here that's I/O bound, and then go back and get some more stuff off the queue. And at some point, the I/O is done. The results are back, and it will then take those results, essentially, and it becomes another event on the event queue, which the loop eventually gets around to processing those results. And so everything just kind of goes around this loop. It's a single-threaded loop. Your code, there's only one thread for your code. So I'm sure we've all heard about that from Node. There's only a single thread. But that's how it handles that. So it's a loop that controls all the interaction in the system, pulling events off a queue, which might be just your code executing or callbacks from I/O. So when we talk about the Node platform, there's sort of 3 main layers or slices. You've got all the Node standard library at the top, which are sort of the APIs you'd expect for file system access and maybe processing streams and buffers and processes and things like that. And then you've got the Node bindings. So that's also Node code, but it's normally C++ native code. So that's binding to the operating system functionality for things like I/O and different things like that. And then at the very bottom these are the dependencies that Node has that aren't written by Node, but that Node leverages. So the first one is V8, Google's JavaScript engine. So you've probably heard about that. It's arguably probably the fastest JavaScript engine. And so that's what Node uses to execute all of its JavaScript. And I haven't mentioned that because everybody said they knew what Node was, but everything is written in JavaScript. The thread pool is a library called libeio. The event loop is libev, and then it uses OpenSSL for crypto, and DNS is an Aries library. So some of those are dependencies that Node hasn't written, and there are bindings to those things that you can. So basically, you might have crypto operations that there's a native binding to the OpenSSL crypto that you can leverage in a Node standard library JavaScript. So I want to show some examples and talk about what's happening in Node land when these examples are executing. So does anybody recognize code like this? Has anybody ever written code like this before? Oh, come on. I should see like every hand in the room up. If you've ever done anything in a browser, you've probably had a timeout where you've wanted to wait for something and execute it, right? So this is probably not all that foreign to you, where you have to pass a function to the setTimeout method, and it'll get executed at some time later. So in this example, 500 milliseconds later. All right, so this is not odd. So if you're comfortable with that, then maybe you might be comfortable with having an HTTP server written in JavaScript. So in this example, line 1 is sort of like Node's import or require step that you need to set up. But then here you're creating an HTTP server on line 3, and you're passing it a function. So that function is what will be called whenever there's a request. And then when this code executes, it's going to execute almost instantly, right, when you start up. And then Node, essentially the event loop, is not going to have any events to process until you get a request. And at that point in time, there'll be an event process, and that function will execute, right? And it'll do lines 4 and 5, and then it'll be, again, waiting for the next event. Serving a static file. So here we're getting a little bit more complicated with our functions. So we're creating a server on line 2. And then on line 3, I guess what I will say is, first, when this executes the first time around, you're going to execute line 1 and line 2, and then you're done, right? And then when you actually get a request, the function defined on line 2 will execute. And then line 3 will execute, and then it'll be done again until the reading of that file is complete. And then when the reading of that file is complete, the function defined here on line 3 will then execute, which is then doing some error checking and then writing out the response. So all of these things happen asynchronously. So one or more loops of the event loop may occur between any of these function definitions. Is this strange? No, it's not strange. Good. So one of the things you might have noticed, if we go back to this one, is that here we're reading a file and we're getting all of the data. So one of the things Node is really good at is doing things streaming. But if your file is really huge, then obviously you can't do that. So this is just an example that would show what you would do if you can't get everything you need in one function call. So in this example, you're going to create a read stream. So let's say you have a huge text file, and you want to be able to read the entire thing and process it. So you'll create what's called a read stream, and you have a variable here, and then you listen for different events on that stream. So you listen for data events, which is it'll read some chunk of data from that file and then call your function with it. Eventually, when it reaches the end of the file, it'll call your callback for your end. And if there's any errors, it'll call a callback for error. So it's very much like actually programming in the browser where you're listening for events and having event listeners. So all of the async API stuff is predicated on callbacks and events. So what are some of the challenges to this? So I think the biggest one coming from not programming asynchronously is when you're doing I/O, you end up with a lot of these nested functions that you have to kind of think about. In the code, really, here all I'm trying to do here is read a file if it exists. So check if it exists and then read it. And it's kind of a lot of code to do that. So the first thing you do is this stat function is just going to check, is basically just checking to see if a file exists. But you can't find out right away. You have to pass it a function so that you can find out later if it exists. And then when that function eventually fires, you have to check if there's an error and return. If there is not an error, you check if it's a file, and then you go to read it. But you can't read it, you have to wait, because it may happen later. So then you pass it a function. So you definitely get into this scenario in Node a lot where if you have to do multiple levels of I/O that depend on one another, you have all these sort of nested functions. And there's ways to deal with that. There's different libraries that make that a lot easier. But see, you have here another example. You're reading a file, and then, well, it might have an error. So if it has an error, then you want to throw something. Otherwise, you want to do something with it. So you get into scenarios like these a lot. And there's some libraries like a library called step and async that take a lot of this pain away. And I can show you those afterwards. So debugging is also a little bit more difficult. Because if you can imagine, let me go back to this code example. Remember what I said here is that when your code initially runs, it's going to run line 1 and line 3, and then it's done. Right? And at some point later, the function you defined here on line 3 is going to execute. So if this function executes and then has an error, what does the stack trace look like? Anybody? Is that? And that's it, right? So you don't have a great idea of where your error actually occurred. So it makes it a little bit harder for debugging things. One nice thing is that there's actually a library, it's an add-on, it's not built into Node, called Node Inspector. So if anybody's ever used like Firebug, or more specifically Chrome's development tools. Anybody? Chrome's development tools? Yeah, so you can basically get all of Chrome's development tools for your Node environment, which is pretty handy. So there's some nice JavaScript debugging and things like that. But it's definitely more difficult to debug if you have errors and callbacks. There is only one thread per node process, so don't do anything really CPU intensive. If you need to do that, then you either can do that in a sub-process, which Node makes really easy to do child processes, or if you want to just put it off on another server and make a request to that, you can do things that way, but be careful that you're not spending too much time doing CPU intensive stuff. It's rapidly changing. So these are the releases, all 12 of them, that we've had in 2012. Yes, that's in the last 2 months. There's been 12 releases of Node. So the 0.6 releases, if you're familiar with Linux, it works very similarly. So the even-numbered releases are what they consider stable releases, and the odd ones are development releases. So they'll change it quickly and fix things quickly and put out new releases. So what are some of the benefits? So I think there's a lot of benefits. Well, first, Node is multi-platform, so there's been a very big push recently to get Windows support up to par. I don't know how close it is yet, but I know that even Microsoft is helping out on that particular project. So if you go to the Node's website, and you actually click on download, it says there's a Windows installer, a Mac installer, and source code. So the one kind of interesting thing is that there's nothing here specifically that says Linux, although it probably works best on Linux. You just have to compile it. There are package managers that often have the source code, but compiling it is really not that difficult, so I just go that route if you want to try it out. It does require Python. Most Linux packages probably already have that installed. I said most. So it is pretty lightweight because there is only one thread, which does help with your concurrency because you can't access anything from 2 places at once. I'm going to, with the whole polyglot programming that's been all in vogue, I'm going to switch that. I'm going to coin the term monoglot programming because you've only have JavaScript on the client and JavaScript on the server. So it's all JavaScript all the time. So if you really hate JavaScript, then you're going to be miserable. But it's pretty handy. I have to say, I've enjoyed not having to do the context switch when I'm doing something in the browser and then doing something on the server. There is something to be said for just doing it all in one language. I don't think it's necessary, but it is pretty nice. It is a fairly popular repository. So this was as of a few minutes ago. It is the second most watched repository on GitHub, just be ahead of Rails, which it passed last November. And at the time when it passed Rails last November, it was #1. So Bootstrap, which was released by Twitter since November, has just gone gangbusters and is actually almost double the watchers of Node, which is pretty insane that it's become that popular that fast. But being popular, I mean, so what does being popular do? I think the biggest advantage is that there's a lot of people using Node, interested in Node, a lot of articles, a lot of people that you can ask for help, which is why being popular at this point in time is pretty handy. For a dynamic language, it's really fast. So I've actually found this website. Has anyone ever seen this website? Yell out if you have. Yes, okay. So it's a site that has several benchmarks, so several benchmark programs that they expect certain output, and people submit code to them in different languages, and they basically time it over a certain number of samples of running the program just to see how fast these languages are. So it's interesting to look at, for instance, against Ruby 1.9. So I know this is kind of hard to see, but I can probably bump it up. So here's the graph against Ruby 1.9. And what's really showing here is Ruby takes more time, right, to run the examples, uses less memory and a little less code. So anywhere between, 1 times to 50 times as long for different benchmarks. So much faster. it's also fun. When I was doing this, I figured, well, JRuby should pretty much smoke it since it's on the JVM. But it turns out not at all. It actually is, V8 is still a lot faster. And actually, JRuby uses a lot more memory. So that one was surprising to me. Is there any in here that anybody would like to see? Anybody's favorite language? Closure. So this one's, I think, more of an even race, although being a Java-based library, it does use some more memory. But then we, PHP.
Under the P.
PHP. What do you think? Except for this first one where it crushes V8. And then I found one interesting when we go to Java. What do we think the story is going to be here on Java, just for fun? Who's faster? Java. Java's a lot faster. So if you really need some serious CPU speed, you still probably want to go with a compiled language like Java or C. Yeah, I mean, if you want to be super fast, let's do C. So that graph didn't change that much over Java. A little less memory, a little less, a lot less. So definitely for a dynamic language, it's really fast. And so the other interesting point, which Joe Ferner asked me to mention when I was showing this, was that if you compare it to something like, let's say Ruby, we can see that Ruby uses less memory. But also you have to think about, we're just comparing one Ruby process and program to one JavaScript V8 process and program. But if you were actually going to have a server that you needed to handle, let's say, 20 concurrent requests, in Ruby land, that's 20 processes. So multiply your memory by 20, roughly. So in the end, you'd end up using a lot more memory. The community. So NPM is Node's equivalent to Ruby Gems. So they call it Node Package Manager. And there are a lot of packages. So currently there are 7,784. So when I put together this slide 2 days ago, there were 60 less. So there's a lot of really good packages out there, and there's plenty of ones that aren't so good either. So it's really easy to create a package and publish it. But there's a lot out there for you to reuse already. Okay, so one thing, would you guys agree with me, at least, maybe I'm completely mistaken, but conceptually, does it seem fairly simple? Yes, I'm seeing some nods. Okay, I have to agree. So I think that's a benefit. I was shocked by this. It's really pretty small. The core is really small. So when I talked about there's a Node standard library, which is the JavaScript files, and there's some of the Node bindings, which is the C++ source files, there's 36 files in each. And they're not all that large. So this is something that you could definitely just read through the entire code if you wanted to, because it's not big. So anybody else surprised by the size? Yeah, a few nods. I think it has a pretty short learning curve. So we've talked about nodes theory, and we've all agreed that conceptually that's pretty simple to understand. Most of us already know JavaScript, so there's no new language to learn, which I think is a pretty big benefit to Node. You don't have to learn a new language, you probably already know it. And if you understand some of the evented programming that you've almost certainly done in the browser, the only thing really left to do is learn some of the new APIs and get some practice in it. So I think it's a pretty short learning curve. So, getting smart. Here's what I would do. Install Node from source. And the reason installing Node from source is really important is that the packages that you could download from the website don't include header files. And many of the packages on NPM have native compilation steps when they install. And so they won't work. So if you install from source, all of those packages that have native bindings will compile properly. Second thing I would do is I would write some small programs. Get a feel for Node, how it works, do some I/O, deal with the whole nested functions and what you have to do there. And then the third one is, since it is so small, I think I would probably tell you to read the source code. After you have a feel for Node, take a look at the source, at least take a look at the JavaScript source to get a feel for what it's actually doing under the covers. I mean, I've taken a look at most of it, and it's pretty readable, and it's interesting to understand how it's actually working. And then the fourth thing I would do is I would re-implement a popular package. So pick some package that's really popular on NPM, and hopefully not too big, and read about what it's supposed to do, and then try to write it yourself. So pick something that also has some I/O, because it's a really interesting way to learn about Node, because you always have a reference implementation. If there's always something you're not sure how you would do, then just go look at how the original authors actually did it. And I think by the time you re-implement some popular package, you'd really have a good feel for how it works. And some packages to try. So of the 7,700 and some, here are 8 to try. So these are chosen fairly randomly, and mostly because these are ones we've worked with before. Dave, you have a question?
Of the 7,000, how many are getting open source products?
I don't know, there's 8 maybe. So Express is a web framework. If you've ever used Sinatra on the Ruby side, has anybody ever played around with Sinatra in Ruby, in the Ruby world? So Express is a web framework that is patterned after Sinatra. So it's pretty nice to use. Async is the, I'll call it the async helpers library that I talked about, that really takes away some of that nested functions that you had and actually makes them much more readable, where you can just define a set of functions that have to operate in series, or a set of functions that can operate in parallel. And it makes a lot of that sort of nesting a lot easier. Persist is a really cool ORM framework, best one I've seen. They're written by Joe Ferner. It really is the best one I've seen. Socket.io is a pretty amazing library for doing some real-time networking. So if anybody's ever heard of WebSockets, it implements WebSockets, but it'll also do things like falling back to techniques like long polling if WebSockets isn't supported. So if has anybody, I guess 11 people, or at least were following along this presentation, Socket.io is the one that's been coordinating all of the I/O for all of this presentation. Ben was asking, what does Node do? Since Node is only single process, single threaded, does it have any facility for handling, using multiple processes or threads? So the answer is that, for instance, if you want to build a multi-process server, you want to take, let's say your computer has, or your server has 8 CPUs. The cluster module in Node will actually allow you to fork new Node processes, and you can actually share the port across those processes. So if a web request comes in to your server, it'll then basically get handled by one of the 8 workers that you've spawned. And so they all run sort of independently. So imagine it's almost like a big load balancer in front of multiple Node processes. And one of the nice things about the cluster module is that you have a built-in cross-process like communication channel. So you can actually send messages between the processes. All right, thank you.